I can solve two-step word problems using the standard subtraction algorithm fluently, modeled with tape diagrams, and assess the reasonableness of answers using rounding. So today you're just going to be working on a few word problems, and you're going to need to use the tape diagrams. And I would say, based on the objective for today, that you're going to also be doing subtraction using the standard algorithm. I'm in the doghouse because I was hungry and kept eating all the big numbers. Can a few people finish these problems for me? If you get stuck, use a place value chart. Now, when I look at these numbers, 900,000s, 8,000s, 900s, 310s. That is called unit form. You've talked about unit form already in this unit, this module. And we're going to compare that number to 807,820. Now, I could write this number out. I could use a place value chart. I could just draw out my place value chart. I could put the 9 in the 100,000s. I could put the 8 in the thousands and the 9 in the hundreds and the 3 in the tens. But I can also look at this number and say, okay, we have a 9 in the 100,000s place. And then I look at my number that I'm comparing it to. We have an 8 in the 100,000s place. What is bigger, 900,000 or 800,000? Yes, 900,000 is greater. So your little alligator mouth is going to eat all the numbers to the left. I want you to look at the next two numbers and compare them by using greater than, less than, or equal to. Remember, the alligator mouth always eats the biggest number. Okay, we're going to go down a few slides here, and we're going to look at problem number 1. A company has 3 locations with 70,010 employees altogether. Their first location has 34,857 employees. Their second location has 17,595 employees. How many employees work in their third location? So if you notice on our tape diagram, we have our bracket that's going all the way across the top. That would include all employees. So 70,010 employees altogether. That's our top number. And we know what the first two are. At the bottom, the first two brackets, we know what those equal, but we don't know what the third one equals. So what do we put in place of an answer that we don't know? If we don't have enough information, or if we don't have any way of being able to say, look at that and say, oh, that's the answer, what do we use in place of unknown numbers? We use a variable. Okay, so I'll give you the top number, 70,010, and I'll give you the variable. Now, your job is going to be to finish this tape diagram and to solve the problem. Don't forget to highlight the important information. Okay, let's look at problem 2. Owen's goal is to have 1 million people visit his new website within the first 4 months of it being launched. Below is a chart showing the number of visitors each month. How many more visitors does he need in month 4 to reach his goal? So we don't know how many he needs in month 4, do we? So what are we going to put in place of month 4? We don't have a number to put there, so what are we going to put in place? We're going to put a variable. So, how many total visitors does he want to have visit his website within the first 4 months? Okay, the total is 1 million people. The variable is A. It goes to the last bracket because we don't know how many visitors need to visit in month 4. So your job is to finish the chart, finish the tape diagram, and then solve this problem using standard subtraction algorithm. There were 12,345 people at a concert on Saturday night. On Sunday night, there were 1,795 fewer people at the concert than on Saturday night. How many people attended the concert on both nights? So let's go ahead and we'll fill in our chart for Saturday. We need to label the bar Saturday, and then the other bar is going to be Sunday. So Sunday night they had fewer people, so that's going to be my shorter bar. But the main question is, how many people attended the concert on both nights? So you're going to have to figure out not only how many people came on Sunday, but how many total people attended Saturday and Sunday. So this is a multi-step problem that I'm pretty sure you can figure out. So I'm going to label your bar for you for Saturday night, and then I'm going to show you where the variable goes, and then I want you to solve this problem, finish a tape diagram, and solve this problem and find out how many people attended the concert on both nights.